The narrative surrounding artificial intelligence has shifted. It's no longer about what these models can say, but about the physical world required to keep them running. We are entering the final week of January 2026, and the industry is focused on a massive scale-up. NVIDIA's latest move, a $2 billion injection into CoreWeave, isn't just a business deal. It's a signal. They are racing to build what Jensen Huang calls AI factories. By 2030, the goal is 5 gigawatts of power. To put that in perspective, we're looking at an infrastructure build-out that rivals the expansion of the global electrical grid. There is a growing irony in the labor market right now. For years, the fear was that AI would erase the need for human input. Instead, the push to build these data centers has created a massive spike in demand for specialized trades. We're seeing electricians and network technicians command salaries that were once reserved for software engineers. This is the physical reality of the digital age. The bottleneck isn't the code, it's the power and the people who know how to wire it. While the US doubles down on massive hardware, China is taking a different path toward efficiency. The release of DeepSeek V4 this Tuesday has changed the math on model training. By using what they call dynamic sparse attention, they've managed to match the reasoning capabilities of the industry's leading models at 40% of the operating cost. This suggests that the compute moat, the idea that only the wealthiest firms can compete, might be thinner than we thought. If high-level reasoning becomes cheap and accessible, the competitive advantage moves away from the model itself and toward how it's applied in the real world. We see this application strategy playing out with OpenAI's Horizon 1000 initiative. By partnering with the Gates Foundation to put AI into 1,000 clinics across Africa, they aren't just doing philanthropy. They are embedding their ecosystem into the social infrastructure of developing economies. It's a calculated move as the company prepares for its highly anticipated IPO later this year. The underlying tension of 2026 remains the same: the friction between rapid innovation and government oversight. In Washington, the debate over regulation is intensifying, with critics arguing that over-policing the industry will only hand the advantage to the East. As of this Tuesday, the race isn't just about who has the smartest model. It's about who can build the most efficient machine to house it. Massive, futuristic AI factory humming with energy, servers blinking in unison. The future of AI is here, but it comes with a cost. Visual? A national power grid map flickers, red alerts popping up. Lights in a city dim. Our thirst for computation is creating a 5-gigawatt problem, pushing our power grids to the brink of collapse. Or visual. Time-lapse of a small modern nuclear reactor or a vast solar farm being constructed next to the AI factory. The solution tech giants are now building their own power plants. Visual. The NVIDIA logo is projected onto the side of a newly built, sleek power station. NVIDIA isn't just a chip company anymore, it's becoming its own private utility. The physicality of intelligence. The transition from digital software to physical infrastructure is not merely a change in scale, it is a change in the fundamental nature of computing. When we discuss the $2 billion partnership between NVIDIA and CoreWeave, we are discussing the birth of a new industrial asset class. These AI factories are specialized environments where the traditional boundaries between a data center and a power plant have blurred. The challenge facing the industry today is no longer just the procurement of the H200 or the upcoming Blackwell chips. It is the procurement of electrons. Reports from energy analysts suggest that the projected 5-gigawatt requirement for these clusters exceeds the total energy consumption of many medium-sized nations. This has forced a strategic pivot. We are seeing these technology firms move behind the meter, negotiating directly with nuclear power providers and investing in small modular reactors. The goal is total energy independence. In this environment, the company that controls the power grid effectively controls the pace of artificial intelligence. This shift is turning tech giants into the modern equivalents of the 20th century oil barons. Entities that must control the entire supply chain, from the raw silicon to the high-voltage transmission lines. The software counteroffensive. While the West builds monuments of hardware, the release of DeepSeek V4 represents a different kind of architectural brilliance. In Hangzhou, the focus has shifted from brute force to algorithmic efficiency. DeepSeek V4 utilizes what engineers call multi-head latent attention. By compressing the data the model needs to remember during a conversation, they have significantly reduced the memory bandwidth required. This is the technical reason why they can match Western performance at 40% of the cost. This development is disruptive because it challenges the compute moat. For the last 3 years, the prevailing wisdom was that whoever had the most chips would win the intelligence race. DeepSeek V4 suggests that software efficiency can compensate for a lack of hardware. If a model can achieve state-of-the-art reasoning on older, more accessible chips, the strategic value of the US export bans on high-end semiconductors begins to diminish. It's been said that we are entering a post-GPU era, where the quality of the architecture matters more than the quantity of the transistors. This creates a volatile market where today's hardware dominance could be rendered obsolete by tomorrow's software breakthrough. The hollowed-out middle. This technological friction is manifesting in the labor market in ways that are often misunderstood. The narrative that AI replaces jobs is too simplistic. What we are witnessing is the hollowing out of the professional middle. In the software industry, senior developers are becoming exponentially more productive, using AI to manage entire systems that once required teams of 10. However, the entry-level roles, the junior developer positions, are vanishing. If the AI can write the basic scripts and debug the initial code, the traditional training ground for human talent disappears. Paradoxically, this has pushed the economic value back into the physical world. The blue-collar gold rush mentioned earlier is a direct result of this digital saturation. You cannot use a large language model to pull fiber optic cables through a trench or to install a liquid cooling system in a high-density server rack. The demand for these physical skills has created a new elite class of technicians who understand both the mechanical and digital requirements of the AI age. This shift is forcing a reevaluation of the educational system. The premium is no longer on the ability to memorize syntax, but on the ability to manage complex physical and digital systems simultaneously. The geopolitics of data sovereignty. As the domestic markets in the West reach a saturation point, the battle for dominance is moving to the global South. OpenAI's Horizon 1000 initiative is a masterclass in long-term strategic positioning. By deploying AI into primary healthcare clinics in Rwanda and across Africa, OpenAI is solving two problems at once. First, they are gaining access to diverse, high-value medical data that is unavailable in the highly regulated and litigious markets of the US and Europe. Second, they are establishing their models as the operating system for developing nations. This is not merely a philanthropic effort. It is a play for sovereign data. When a nation's healthcare, education, and administrative systems are built on a specific company's model, that company becomes a permanent part of the national infrastructure. This creates a level of vendor lock-in that is nearly impossible to break. For OpenAI, as it prepares for an initial public offering, this global footprint is essential. It demonstrates to investors that the company is not just a provider of a chatbot, but a foundational utility for the global economy. It is a move designed to justify a trillion-dollar valuation by proving that AI is the new electricity, ubiquitous, essential, and controlled by a few central players. The regulatory paradox. However, this global expansion is happening against a backdrop of intense domestic scrutiny. In Washington and Brussels, the debate over AI safety and regulation has created a massive compliance burden. Tech leaders are now warning that this focus on catastrophic risk is overshadowing the need for competitive innovation. The fear is that while the West spends years debating the ethics of every new feature, open-source models from the East will continue to iterate at a much faster pace. There is a growing consensus among economic analysts that we are seeing a regulatory paradox. The laws designed to protect the public may actually be concentrating power in the hands of the few companies wealthy enough to afford the legal teams required to comply with them. This leaves the middle market startups in a difficult position. They are either acquired by the giants or they fail under the weight of regulation. Meanwhile, the open-source movement continues to thrive outside these regulatory boundaries, providing high-level intelligence to anyone with a computer and an internet connection. Conclusion: the two paths. As we conclude this analysis of the state of AI in early 2026, two distinct paths for the future have emerged. The first is the path of high-capital closed systems, typified by NVIDIA's massive factories and OpenAI's proprietary models. This path offers safety, reliability, and immense power, but it is centralized and expensive. The second is the path of efficiency and open-source collaboration, typified by DeepSeek and the global developer community. This path is decentralized, cheap, and fast, but it carries its own set of risks and uncertainties. The tension between these two models will define the next decade. It is no longer a question of whether the technology will advance. That is now a mathematical certainty. The real question is who will own the infrastructure of thought. Will it be a handful of trillion-dollar entities controlling the power grids and the data centers? Or will it be a global, decentralized network of open-source models that democratize intelligence at the cost of centralized control? As the builders in the trenches of these AI factories can attest, the answer is being written in silicon, steel, and code every single day.